Okay, moving on to utility cost tests. There's a number of standard tests, and I'm not going to go into a lot of description here. These are described in the California Standard Practice Manual. California really leads the country in defining and using these kinds of tests applied to energy efficiency, and similarly to demand response programs and distributed generation. So basically it's looking at cost effectiveness from different perspectives. From the participant perspective on the one hand, at the other end here we have total resource cost test. It's sort of a societal perspective, although there's an additional societal test that includes some externalities and non-cash sorts of things. We implemented, with the help of E3 in particular in BEopt, the first 4. The societal test is a little fuzzier because of the uncertainty about what value should be attached to externalities. So these are implemented in BEopt. Just a little sketch here. Basically, there's a range of things that one looks at, and how they get combined determines the test from the different perspective. So, for example, from the participant, bill savings are an important benefit, as are incentives, and then there's the cost of the efficiency or the PV, and those combined together give the participant's perspective. From the overall total resource cost test, it's a little different. Bill savings are kind of a wash or a transfer payment, and other factors come into play in terms of the avoided cost, in particular for utilities providing energy to participants. And rate impact, some things that are a benefit from one perspective become a cost in a different perspective. So there were 2 approaches that E3 developed in this project for addressing utility cost tests. The first is the integrated approach, where this NREL worked with E3, integrating these calculations into BEopt using avoided cost, hour-by-hour avoided cost data, actually hour-by-hour over a 40-year time period, so that we have predictions for future utility avoided costs. And so that's what we call the integrated approach, and everything that I'm going to describe in the rest of the presentation revolves around that approach. There is an alternative approach where outputs from BEopt are fed into the E3 calculator. This gives, for one thing, a quality control and a check on the integrated approach. It also has some flexibility that as there are changes to procedures in calculating cost tests over time, or if one wanted to explore those kinds of changes, they could be done offline here without having to make modifications to BEopt. But for most users, I'd say the integrated approach is important. Both were, initially in the project, we were looking at the pros and cons and thinking about deciding which approach to use. We ended up implementing both. So there's quite a lot that goes on in the integrated approach. The building simulations predict the load impacts, the savings in the retrofit or the design building versus the reference. And so again, those are hourly results throughout the year, and those get combined or multiplied by the avoided cost at the utility level, and that's done over a number of years for the analysis period. We have the 40-year avoided cost data set, but the user can decide what analysis period, often 30 years, is used. And so then those kind of utility impacts are passed forward for certain of the cost tests, like TRC, RIM, and program administrator costs. Utility bill tariff structures and rates here get multiplied by the load impacts for electrical consumption, getting yearly results. Again, this is 8760, this is 8760, and also done over an analysis period with discounting to get the utility, the bill impacts for the participant cost test or the ratepayer impact test. So all that's built into BEopt. Again, it's hourly, so in a mild part of the year, like April, there's variability from hour to hour throughout the day. Under more extreme conditions, say in August, there are certain days where the avoided cost, either for energy and capacity or transmission and distribution, can really peak up, and we want to account for what's happening in those days in terms of doing the cost test evaluation. And certainly if one was using demand response, again, that may be active on these particular days. So in terms of the BEopt interface, just real quickly, this is done in California mode for the California climate zones. In some climate zones, there's more than one utility service territory covering that climate zone, so the user needs to specify which utility applies, choose the appropriate rate, and et cetera. And so those are inputs. In some cases, I think one climate zone, actually for the Bay Area, there's the avoided costs are different between the San Francisco Peninsula and the East Bay, so that's again an input. Other inputs include the net to gross ratio, that is how of incentives spent, how many of those effectively purchase the desired benefit in terms of changes of energy use versus free riders, for example. There's an option here to introduce the sort of the administrative costs per home for a particular efficiency program. So when one launches an optimization in BEopt, this is the run screen. So if you push the button to run for a particular case of a particular type in terms of the type optimization, there are some choices now in BEopt. So a question is, what is the objective function for the optimization? It used to be energy-related cost, which is actually pretty similar to the utility test for a participant cost. But now one can select which cost test one wants to optimize for, and also on the x-axis as a function of what. So originally BEopt was done for source energy savings, but in California mode, often time-dependent valuation energy savings are the appropriate selection for the x-axis. So this determines the nature of the optimization during the sequential search. In this case, total resource cost test is optimized to find the most cost-optimal ways that maximize the net present value of the TRC as a function of time-dependent valuation. So if this would then be simulation optimization results as a function of that. I have a dozen cases here looking at the first case with a particular utility rate. We see these results, in this case, participant cost test results optimized as a function of TDV. And so having gotten these results, having run this particular optimization, one could then right-click here for this graph display, specify y-axis, which the optimization was done for participant cost test, but if I would like to now display the total resource cost test instead, I can do this right-click pop-up menu sort of thing and click here, and the display will change, and now I'm seeing the total resource cost test as a function of TDV. One thing to note here is now we are seeing a few gray points above the black curve. Now the black curve represents the results from the optimization, which was optimized for participant cost test. So what those are the same points. It's the TRC values for the building designs that were found optimal for the participant cost test. But this is showing that there are actually some other designs that achieve a higher TRC. And if we went back and optimized on TRC, we might find some even better designs because we would be searching specifically as the sequential search proceeded for TRC maximum values. So in BEopt, you can choose the cost test to optimize on and look at the results for that cost test or for alternative cost test. And it's kind of up to the analyst to decide what the original optimization should be done on. One could think about having a multi-objective optimization that had some weighting factor that simultaneously optimized on more than one cost test. But at the moment, you choose, optimize, and then visualize the results across different tests. So for example, if I go back here and come and instead switch to the rate impact measure, the RIM test, I get a different type of curve. Now in this case, in the previous instances, it was net present value, and we were looking for maximum participant cost values or TRC values. In the case of the rate impact test, they tend to go negative, and one wants to find the smallest negative value. So, but here again, since this was optimized on participant cost test, there are some outliers on the other side of the boundary here when we go to this particular cost test.